Okay, so we're going to work on chapter 2 here. We'll spend the first hour dealing with fractions and just basic operations, but we're going to dive into just exercises. So you're not going to see, yes, James, these notes here that you see here with my annotations and the colors and the pen and all that stuff, I'm going to convert this to a PDF at the end of class and I'll put it on Blackboard. You're welcome. Plus you'll have the raw recording, and then I'll take the recording and edit it and then cut out some of the, the delays and any little hiccups and then put that on the YouTube channel if you want to see it there as well. Okay, so we're going to work on basic operations with fractions, and then in the second hour we're going to talk, and we'll do exercises, not just like, detached questions where it's just fractions without application. I want you to see exercises that have diagrams and such. And then in sections 2.4 and 2.5, we're going to just talk about leading into precision and accuracy, but we're going to deal with decimal calculations. So that's about it. So the book here, this one here, as I mentioned, James asked in the chat there, I've already like annotated it and put kind of just colors here and there to and highlight key things or formulas that you or methods that you should know. So some of this stuff here, I'm not going to read line by line. I just want to do exercises, especially in the earlier sections where you're coming into the course knowing, generally speaking, what a fraction is, but maybe you're rusty at it, or maybe you forgot how to process the operations. So there's a very lovely treatment if you want to take a more basic route and kind of study through this chapter. And you can definitely read through some of these pages to go through that. The author of this book does an excellent job. Oh, you're welcome, Jacob. The author of the book does a very excellent job of walking you through how you actually deal with long division and how you can convert from proper to improper. I'll do all of this stuff in the exercises, and plus the way that I show you might differ a little than the author, so at least you have two different perspectives on how to do things. Also, you'll notice that if you have, there's various types of calculators in the market, but most times the operations with calculators include fractions. So you can see here that the author takes the time using, although there's no specific calculator for this course, the recommended calculators are the two Casio ones mentioned here. And it shows you in detail how you can do the calculations with fractions on your calculator. Many students are shocked, like even students that I TA'd, even at U of T back in the day when I was a TA there, or even lecturing there. They're like, I can do fractions on my calculator. I mean, they knew they could do it, but they never really paid attention to how they do it because it was sometimes awkward. So it's kind of shocking anyway. So when it comes to fractions, we're going to still use the rules of BEDMAS, and we'll see that it all kind of works the same way. So the only thing that you might be rusty at, as I'm kind of scrolling through the notes here, is dealing with the basic operations. So what I've done here is done a one-pager on reviewing your fractions. So what I'd like you to do, I got 3 of them here. There's also subtract. Although adding and subtracting are essentially the same process in terms of setup, what I want you to do is I want you to take like maybe 3 minutes or 2 minutes and just try to do all 4 of these questions. Okay, so just try that on your own. See what you remember. So I'm going to just turn the mic off and give you 2 minutes. I'll just look at the clock here on my computer and okay, you got 2 minutes. I'm not going to say anything, Cosmo. I want you to see what you remember. That's all. Okay. I will answer everything. Just 2 minutes. Okay. I want to just see what you do. Okay. Just another 30 seconds or so. Again, the exercise here is just to kind of, I mean, you were probably not thinking you were going to be asked this right off the bat today. So it's nice to see what you remember just out of the blue if I ask you something. Because if you get something right, let's say you get them all right, then that's a good sign that your fractions are good, and don't worry, you can probably just go to the exercises and try a few harder questions. Okay, let's see what we're doing here. So let's take a look at the first one. So the first one, I'll just state the answer because it's you've had time to practice it. So when you're multiplying two fractions, you simply just multiply the tops and you multiply the bottoms. Now I should say numerator and denominator, but I'm just being economical. And yes, you can definitely reduce that. So I'll do that as well. Some people like to do it a little bit differently. I usually do this. I look at the question and I'll be like, look, I can reduce the 2 with the 4, as long as I reduce something on the top with something on the bottom. But I don't mind if you do it either way. This second question, though, it does require a little bit of extra work because with division, some people like to say cross multiply. I'm going to do it with the extra step, the way that I was taught a long time ago. Whoops, maybe I can't do that. So what I'll do as my first step, yeah, I'm going to multiply by the reciprocal. So just turn it into a multiplication question. So we say you invert and multiply. So in this case, you'll get 6 out of 28, or 3/14. Thank you very much. Okay. By the way, I said easiest here. I think most people hopefully will agree that multiplication of two fractions is the easiest. If you grab most any book, especially with algebra and fractions, like fractions with algebraic expressions, then you'll see that they usually teach the multiplication and division first. Yeah, and because division only requires a little bit of a shuffle here with the reciprocal, it's okay. Now, in this case, addition and subtraction, do you remember getting the lowest common denominator? So I'll just say here LCD. But don't forget that you get the lowest common denominator. In this case, the lowest common denominator is 10. So what you can do is you can take the first fraction and multiply by 5/5. Trying to draw this here nicely, and then take the second fraction and multiply by 2/2. So we get 5/10 and 6/10. I don't have a lot of room, so I'm going to just work it sideways here. So that's 11/10. This answer is correct. If you want to write it in proper form, as Huria did there, yes, you can write it as 1 1/10. Going between this and this, if you're a little bit rusty at that, there's different ways of doing it. What I usually do, I mean, you can do long division. You can do long division. And then do 10 goes into 11/1. 1 times 10 is 10. And then this number here is the remainder, and that goes here. Okay, what part of it, Cosmo? Which part? Just because there's the common denominator. How come the 5 is on top? Oh, okay. I can answer that in 1 second. So the idea here is that I can't add these together unless the denominators are the same. These have to be the same number on the bottom. So what I say to myself is, look, this 2 has to turn into a 10. How do I turn the 2 into a 10? I multiply by 5. But whatever you do to the bottom, you have to do to the top to be fair. So that's why I do 5/5 here, because whatever I do to the bottom to turn this 2 into a 10, I need to do the same operation to the numerator. So in this case, I have to multiply the top by 5 as well. In this case over here, I want to turn this 5 into a 10, so I can multiply it by 2. But whatever I do to the bottom, I must also do to the top, to be fair. This number here, 5/5, 5 over 5 is equal to 1. And I know that when I multiply anything by 1, whatever I multiply something by 1, I get back that something. I don't wreck it. I don't change it. So that's why I'm allowed to multiply each of these fractions by, for example, 5 over 5, because that's a 1, or in this case 2 over 2, because that's also just a 1. Hopefully that's a bit better. What's the lowest common denominator for the second one? Awesome. 35. Very good. So I need to multiply the first one by 7 over 7 to turn that 5 into a 35, but also to balance it out. The second one I need to multiply by 5 over 5 so that I can get this to 35 as well, but I must also multiply the top by 5. So this becomes 14 over 35 and 5 over 35. Can someone confirm 19 over 35? I think Huria just didn't put the 1 in front. Oh, shoot. My apologies. Huria, I apologize. See that? This is what happens when you only had one sip of the coffee this morning. My apologies, Huria. I'm so sorry. You are on point. Look at that. All right, strike one. No. I'm actually drinking, today I'm drinking green tea. Just having the green tea. Okay. Yeah, this one is it's a Sanjit, it's a matcha green tea. I was at my friend's restaurant the other day and he had some he served me matcha green tea and I was like, "Okay, I'm taking some of this home, buddy." So I took some of his green tea home. If he ever watches the YouTube video, he's not going to be happy. Anyway, so yeah, here are some questions that you can find on page 9. So what I've done is I highlighted a bunch of questions, see, 7, 8, 9, 11, 13, and they carry over, and there's questions with diagrams, a lot of diagrams here, see that? So the blue ones, these are just like the ones in your notes, sorry. I've highlighted all the ones that I'd like to try with you today, but obviously there might not be enough space. So when you're doing these questions, and there's some more on page, let's see here, there's some more on page 12. I got a little bit ambitious, and I said I'd like to get all of these done in addition to the next section. So we're going to spend about 20 minutes trying to do as many of these as we can. It might be unrealistic that we answer all of them, but we'll see how it goes. So what I did was I screen captured all of those questions and I put them onto a blank page. So what you see here is just the aforementioned pages where I've extracted several questions. So we can see 7, 8, 9. These are all questions involving just the basic operations of addition and subtraction and multiplication. And then we have a mixed fraction. Yeah, it's what was it, 9 over 35. Norris, I think it was 9 over 35. Okay. All right. You're welcome. So I'm going to do these questions here. I'm just going to type them. If you don't mind, the drawing thing's a little slow, so I try to type more than draw. So it doesn't look like I get to draw for you too much, the sensation of like writing it by hand. But I hope that you can appreciate it. Anyway, so what do we do for this question? Let's zoom in here. Common denominator, yes. So we're going to take the half and we're going to multiply by 3 over 3. We'll take the 1/3 and multiply by 2 over 2. So that's 3 out of 6 plus 2 out of 6, which is indeed 5 out of 6. Nice work, Matthew. And anybody else who got that question right, that's fantastic. So since these questions are a little bit more just quick and not really that applied, I'm going to go a little bit quicker with these questions. But you can always revisit the recordings if you find that I'm doing this a little too fast. When we do the application questions, I will certainly slow down. So I have the question over here, so I'm not going to copy the question this time. I'll just put an equal sign. So we need to get a common denominator here of what? Yeah, you got to get out of 20. Yeah, so the common denominator is 20. So we're going to multiply by 4 over 4. And then we'll take away a quarter times 5 over 5. So that's 12 out of 20 minus 5 out of 20. And this time I remembered to subtract. So all good there. Awesome. I hope you don't mind this pace. I'm not trying to, like, squeeze you too much here. We need to go a little quicker here. Multiplication. I'll put a happy face there. I like multiplication. Top times top, bottom times bottom. Reduce. Okay, so for the previous one, we need a common denominator. So I'm multiplying the first fraction by 4 over 4 and the second fraction by 5 over 5. And then that way the denominators are both 20. Okay. So we're on to okay. So I need to establish a little bit of a pace here. If some people need a little bit more time with a question, if I'm doing the same question twice, like these questions here are basically kind of the same thing. So the first one I do slower, the second one I do a little faster. Otherwise, we're not going to have time to do some of the harder questions. So if anybody does need like more time to do a question, they may have to again review the video, the recording, because otherwise we're not going to have time to do some of the harder questions, and I need to make sure I do those with you. In question 11 here, we have a little bit of a nuisance because we have mixed fractions. So the idea here is to get them into improper form. You can also actually take out the whole parts if you want. That's actually, the way that I do it's a little bit different than what you might see in a textbook. Thank you. So in the first case, we have 7 over 3. In the second case, we have 3 over 3. In the last case, we have 13 over 4, 3 over 2, sorry. Thank you for those numbers, Matthew. Now, for anybody that's like, how did I get those numbers? I'll show you a sample calculation of one of them. So let's do a sample calculation for one of these. I'll do the first one. Okay, so how did I get 7 over 3? You do 2 times 3, and then you add the 1. Because there are 3 is the denominator represents, you need 3 over 3 to have a whole. So you're going to have 2 times 3, or in other words, 6 thirds makes 2 wholes, and then you add 1 to that. And you can apply the same pattern to the other fractions to build it. So if you do this here now, the common denominator is what? What's the lowest common denominator? 12. Very good, Maria. Okay, so the first fraction, you're going to multiply by 4. So 3 times 4 is 12, and 7 times 4 is 28. The second fraction, you need to turn the 2 into a 12. So you're going to multiply by 6. So 2 times 6 and 3 times 6. The third fraction is going to be going from 4 to 12. So we need to multiply the 4 by a 3. But we also need to multiply the 13 by a 3. And then you just add those together. So 28 plus 13, sorry, plus 18 plus 39. What do we got there? What do we have there? 85. Confirm. Can someone confirm 85 over 12? Thank you. And you can also convert that into proper form if you like. We talked about this last time about counting in 12s. So that's going to be, what, 6 times 12 is 72. 7 times 12 is 84. So that's 7 and 1/12. Okay. So the alternative to this question, if you don't want to answer it the way that I showed you, you can do it differently. So an alternative way, just do 2 plus 1 plus 3, which is 6, and then do a third plus a half plus a quarter. Now I'm gonna just do that, the whole number 7. I did 85 divided by 12. I recognize the following. I'm using the following statement, Nikolaos. I know that 7 times 12 plus 1 is 85. I just know that from my mental math. I'm dividing 85 by 12. So the alternative is down here, you do that. So that's going to be 6 plus 13 over 12, or 6 plus 1 and 1/12, or 7 and 1/12. Okay, I don't want anybody to get scared of what I'm writing on the side. If you're wondering how would I do this in my head, I always like to figure out a way to do it in my head, because then it makes me confident, and I can also not use the calculator. So this is how I would do it. I would ignore the whole numbers, add up just the fraction part, which would be 1 and 1/12, just this piece here, and then add that back to all the whole values. Because adding 1 and 1/12 to the number 6 is easy. If I add the two numbers here in red together, that's pretty easy. So hopefully some people in the chat like what I did on the side here, but it's not mandatory. Some order of operations questions. So with these questions here, we're looking to do BEDMAS. So we can apply BEDMAS here. So what would you do first in this question? What calculation would you do first in this question? That's correct. Matthew says the brackets, and sorry, the subtraction, because the subtraction occurs in the brackets. So that's going to equal 3/8 times, whoops. And I'm going to do that on the side. I'll do that 1/2 minus a third on the side. So the lowest common denominator is 6. So the first fraction I'm going to multiply by 3 over 3. And the second fraction by 2 over 2. So that equals, and I can put that right here. And then you're basically just cruising along. That's 3 out of 48, or 1 out of 16. You can reduce. I understand that some people might be kind of feeling rushed through these questions. The idea for these shorter questions and not really applied questions is that I have them recorded. I have everything recorded that I'm saying and doing, so you can look back later if you miss an example or if it's going a little bit too slow. How did I get 3 over 48? I multiplied the top by the top because it's multiplication here, right? So multiplication. So this times this times this. You're welcome. Okay, this question here, I'll set it up, but I won't do this one fully because we need to move on to some application questions. So I'll just say like this question here. You could write it like this. You don't have to, but you can write it like this. You could rewrite the question like that and then work through the brackets first, and eventually you'll get somewhere useful. So in this case, you would do the brackets first. I'd be shocked if it was 1. I'm not saying it isn't. I'm just shocked. I got 3/8 there and 5/8 there. So then it becomes 3/8. So that step I just did, from here to here, I did the subtraction and the addition in my head. Obviously, you would do those by hand, but I'm just kind of treating this question on a bit of a higher level so that I don't run out of time. In this case, you're going to get 24 out of 40. I don't think it's 24 on the bottom. I think it's going to just be, that's okay. I think you read it as a plus sign. All good. So what I want to show you quickly here, I'm going to do this on the side here. This is a shortcut that I would use, okay? I would not answer the question this way. I don't do it this way. But this is not something you're going to see in the textbook. So this is what I do. Take a look at all the fractions. What is the lowest common denominator for all the fractions? And hopefully you would say that everybody is an 8. Yeah, it's an 8, right? So what I want you to imagine this is we're going to do 8 times the entire numerator and 8 times the entire denominator. I know that sounds weird, but watch what happens. So what's 8 times a half? Well, what's half of 8? Well, that's 4. And then 8 times an eighth is 1. And then you do the same thing to the bottom. 4, and then you multiply by 1/8. What I'm doing here in pink, you don't have to do this. I'm just showing this. Maybe there's a few stronger students that are like, oh, okay, this is way faster and I can do it this way. Whenever you have fractions inside of fractions, you can do some really fun stuff. I'm glad you like it. Yeah, this is really fun to do, especially when you have algebra. So I'm just taking a look ahead at the next section to make sure I didn't miss anything. Okay, good. I'm not trying to do anything, out of turn here, but I'm trying to make sure that we are on pace to cover everything. So anyway, here's another question. Maybe these numbers are difficult to read, so I'll just type it down here as well. That little measurement in there is 2 3/8 of an inch. So if you're wondering what that little measurement in there is, that measurement there was 2 3/8. as well as that measurement over there. So find the distance x in the diagram if the holes are equally spaced. Okay, so the goal here is to set up an expression for x. So I know that x equals 2 3/8 plus a bunch of stuff, and then 2 3/8. So the issue here is, what about the middle? What is the middle? So we're talking about this. Whoops, my pen is not alive here. Hang on. We're talking about this plus this plus this. Count them with me. 4, 5, 6, 7, 8. How long are each of those 8 measurements? Well, they're that. It's 8 times that. So that's what goes there. And there you have it. I'm going to put a bracket on this 1 3/16 because it does look a little bit strange. So now you can actually just simplify that and be on your way. Because this calculation involves mixed fractions, if you're going to do it by hand, you might as well make them improper. So let's see how that works here. So 2 times 8 is 16, plus 3 is 19. And then here we have 19 over 16 for that bracket. And then here we have 19 over 8 as well. Can someone confirm in the chat that they agree with these numbers? Awesome. One more thing. That's a multiplication in the middle that we have to deal with first. So I'm going to make that 8 over 1 so that it's easier to read. That step there, I can just copy and paste that. You don't have to rewrite that step because that's annoying, because obviously you're writing this by hand. So just make it 8 over 1 right there immediately. So this step here that I have is just, I'm taking advantage of copy and paste a lot. So this time, I'm going to actually use a shortcut in terms of reducing the fraction instead of multiplying large numbers. So you see this 8 here and the 16, I'm going to reduce it to make it 1, and I don't have to make it 1 and 2, but I'll do 1 and 2, that's fine. A smarter play would be to make the bottom 8, because you see that we have addition coming up later. So I think that actually the smartest thing to do is to actually just reduce this by 2. So I'm going to make that a 4 and an 8. So I'm kind of preemptively seeing that the LCD is 8, and I'm taking advantage of the fact that I need an 8 later. So this is a little bit unorthodox, but it's okay to try a little bit to be creative, especially if it saves you writing. So 4 times 19 is 56. And then of course you have 19 over 8 again. And now you're in the home stretch because everything's out of 8. Why are we dividing by 2? Because Matthew, wouldn't it be nice to have an 8 here? That's why I'm doing that. I'm reducing the fractions so that the lowest common denominator matches everywhere. You don't have to do that at all. You don't have to do that at all. Oh, sorry, that's 76. Thank you. Thank you, Cosmo. Yeah. So that's 76. I just typed 56 on my keyboard. I'm a keyboard ninja. I type too fast sometimes for my own good. For my own good. Anyway, what's 19 plus 76 plus 19? Is that 114? Yeah. Why didn't you divide the 19? Because you're gonna add the two fractions together later. How did I get 19? Oh, from here. So I got 19 because I turned, for the question about 19, I turned this fraction 2 3/8 into 19 over 8 using the proper to improper conversion. So 8 times 2 plus 3. That's how I got the 19. Thank you, Kushi, for the number there. 76, I did 4 times 19. When you're multiplying, you multiply the top by the top and the bottom by the bottom. You're welcome. Now, if you manually divide, that's good. I'm glad to hear that. Now, if you manually divide 57 by 4, I think it's 14 1/4. Can someone confirm? Yeah, 14 1/4. The 2/8 reduces. Thank you, Matthew. I don't like that it's doing that weird fraction business. There we go. And don't forget your inches. Okay. So there's more of these questions that we can try. I'm going to just show you here. I've highlighted a few more. There's number 19. And there's also another one involving a diagram on question 20. I just added the numerators together because they have the common denominator. Because they have a common denominator, you just add the numerators together. And then I reduced it because I noticed here that they're both even numbers, so I reduced it. By 2, yes. You're welcome. So I think we're going to move on to the next section here. There was a question 19 here and a question 27. I'll show you the setup for 27, but then you can finish it on your own. So let's set up an equation together for this question, and then we'll move on to the next section. So it says if each of the flutes here is 7/16 of an inch wide, and then it says find the width of each of the open spaces. So I'm just going to make just a word formula and say here, how many flutes are there? Flutes are the like the top parts. Excuse me. 1, 2, 3, 4, 5, 6, 7 flutes. So it's 7 flutes plus 1, 2, 3, 4, 5, 6 open spaces. So 6 spaces equals 4 3/4 inches. This is kind of a word equation for what's happening. So once you have a word equation, then you're good to go. Just toss in the numbers or the variables that are associated with each of those quantities. So 7 times 7/16 plus 6x, because x is the variable that you're solving for, equals 4 3/4. So what you would do here is simplify and solve for x. I do want to move on to a future question, so I don't mind showing you some of the intermediate steps, but I'm not going to explain to you the steps. I just want to give you some footprints or foothold to kind of finish the question. So what I'm showing you here, I am skipping some steps because I need to move on. with you. So eventually you're going to get 49 over 6. Thank you for the chat, people. I know that you're trying to help each other, and I appreciate that. I'm just going to say here, subtract the two fractions. So just giving you a hint there. Of course, you can look. I'll post this on Blackboard later. Today, actually, just at the end of class, I'll post it on Blackboard. So we do have, we're going to be taking a break shortly, but I do need to do a little bit of discussion about practical fractions in the imperial system. So this is where it'll be very keen for your memory skills that you know how to do these fractions. So in the hello? Sorry, did someone have a question? Okay. So it's very, very important that you know fractions out of 2, 4, 8, 16, and 32, especially in the imperial system when you're reading measurements. Oh, it'll refresh, Matthew. Okay, yeah. Sometimes it does that. Sometimes the screen will just turn off and on. It does it to me too, actually, while I'm teaching, maybe like once or twice an hour. Again, I think it has to do with the bandwidth on Blackboard, because it's we got 30 something people here sharing the bandwidth. Never mind that there's probably 100 other classes going on at this moment with other schools and departments. So anyway, I'm just going to say here, I've highlighted it on the next page. You should know how to pronounce these quantities. So I highlighted some examples here. I'm not going to ask you too much to write or communicate. On occasion I will, like on each assignment, I try to get you to write something, but it's not going to be the centerpiece of the course. This is just because maybe there are some students that are not learning math with English as their first language. So we have to remember that there are people coming from all over the world to George Brown and other, obviously, many post-secondary schools, and they're not necessarily versed with English as their first language. So some of the technical words, even saying a fraction properly, might be obvious to you, but not might be obvious to one of your neighbors. So that's why it's good that I just highlight this and just say, look, brush up on how you pronounce things and say things correctly, and this way it just looks more professional when you're interacting in everyday life. That's good. That's all. So what I've done is I've taken a look here toward the end of this section, and it just says here, write the correct name for each of these. Because some people are like, look, sir, do I have to do all of these questions? I'm gonna pass out from boredom. Because maybe you don't want to do all the questions. I can understand it's a lot of questions. So what I did is, look, I highlighted some of these in blue, and I said, okay, if you can do those ones, you should be fine. But I'm not saying just do these questions. I'm just saying, like, make an honest effort that you can practice some of these questions, and that you can obviously communicate correctly. This section is very short. It's more communication oriented, so there's not really a lot of exercises that are calculation oriented. I did find a couple of questions involving diagrams. There's this one over here that's asking you to find the length of x here. And then there's also this question here involving, looks like a belt system. So I flagged this one here to try. We can definitely set it up if you like. But once you set it up, I think it should be good to go. To be honest with you, I can't read that measurement there. I think it's 3/8. What do you? It should be 3/8. It's not a 4. Yeah, it's 3/8. Okay. Yeah. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Obviously, when these books were written, the author of the book was not expecting a pandemic to occur, because these books are usually printed and distributed to you in physical form. Yeah, we're gonna get a break at 10 for sure. Usually I do it on the hour, and then I give you a 10-minute break. So let's see if we can set this one up so we can move along with our lives. All right, here we go. So I'm gonna do some coloring, if you don't mind. So this is 2 3/4. I had it all the way across. That's 2 3/4. That's a radius. And what else are we given? We're given this radius. Yeah. Now, can someone tell me what is this length here, or how do you get this length here? This pink thing here. What's that pink length? I think it's a third minus a quarter. What do you think? Can someone agree, confirm with me? A third minus a quarter? Yeah, see, it's this minus this. Because these are imagine a clock, it just goes around, whatever. This arrow, this length, that length, the difference should be this. So that's good. So that's a quarter. Now, what about over here? Let's do that on the other side, because we need that other information here. What's this little length here? Well, do we even need that length? I don't think we need this length. I don't even think we need it. Because ultimately we're trying to get x. So it looks like I think we're good. I don't even think we need this length here. I don't even think we need it. So what I'm going to do is this. I'm going to just put a little, I like to draw a little border around it. So let's talk about that. If you can kind of compare the top and the bottom edges, I think it's better. So this length here is a quarter of an inch. In fact, we don't care about this. So let's delete that. I don't think we need that. That's a quarter of an inch. And how much is this? 3/8. Very good. So I think we have it. I think sometimes you get extra information on a diagram and it's overkill. I'll write down the formula. The good thing is this. Although I don't rehearse the questions, and I really honestly don't, because I think that's cheating. I mean, I'm cheating with you if I just know the answer already. But also, I have another 33 students in this chat that are just as able as me to read a picture, if not better. So we help each other. So I can say, look, the top edge, yeah, I think I'm gonna be there in 2 seconds. Thank you, Matthew. The top edge is x plus 3/8, and the bottom edge, what I've put between the two blue goalposts, if you like soccer, is a quarter plus 2 3/4. Like that. And as I think Matthew put in the chat there, 2 3/4, you can replace that by 11/4 using the proper to improper conversion. I'm going to just add up those two numbers on the right. These numbers are so nice. See that? 11/4 and 1/4 is 12/4. That's nice. And then 12/4 reduces to 3. So x equals 3 minus 3/8. So I'm just going to double check the answers. I'm curious if we got it right. And my friends, we got it right. I just checked the answer key. If you do 3 minus 3/8, by the way, this calculation, you should do this in your head, okay? This you can do in your head. Don't be scared of it. 3 minus 3/8. Instead of thinking it like that, we're going to take a break in 1 minute or two. If I want to do 3 minus 3/8, I don't do that. You know what I do? I take the 3 and I put 2 in the bank. I don't touch the 2. And then I do 1 minus 3/8. That's how I do it. I know it looks a little bit overkill, but this calculation, what I'm saying, it should be easy for you. Because it's a whole. What's a whole minus 3/8? Well, it's the leftovers. So it's 5/8. So I'm not saying that if you can't do it in your head that you're no good or something. I'm just saying like you can do it with good practice. With practice, you should be able to do that in your head. That's what I'm trying to say there. Okay, I'm going to stop recording. Let's do that here. We're talking about how you can round different types of ways. So in terms of, these are more like communication-oriented ideas. We have here, you might be told to round to a certain number of decimal places. If you take a look at the assignment 2, I think that I do ask you to round in different ways, hopefully. You can also round to a certain precision. In this case, sorry, the first type of rounding is related to precision, whereas the second type of rounding is related to accuracy. So we're going to differentiate between precision and accuracy next class. It's more like a science kind of a lesson, something you might have seen in like chemistry or physics in high school, if you've taken those courses, where the words precision and accuracy are often confused or maybe just not really clearly understood. So we're going to do some exercises in this first little chunk here of the second hour involving communication. And I'll just mention here, there are some rules for significant digits. So the rules are presented here. But I'm going to talk about significant digits through a series of examples rather than just saying the rules to you here. This will be a little bit easier for you to process as well. And then there's a third type of rounding, and this is more of related to the imperial system. But I mean, you see it in the decimal system as well. So, like, imagine that you're measuring something with a meter stick, but then you need to use that measurement to, for example, purchase materials. But those materials are measured in the metric system. So, for example, let's say that you measure a room, or you're measuring I don't know, like a door jamb, and you want to put some molding at the top of the door jamb because maybe the old molding broke or is damaged, and you measure it, and you measured it in like meters and centimeters. So you got like, let's say I don't know, 5 meters, and then you go, that's not that wide of a door, and then you go to Home Depot and you're like, oh, it's in feet and inches, and you need, what is it? Is it two and a half feet, and then how many fractions of an inch? These are the kind of reasons that you might end up dealing with the third type of rounding, where you have that metric to imperial situation, or perhaps you're just being asked for very low tolerances to the nearest hundredth of an inch or something, which is also very common if you're dealing, for example, anybody who are coming out of a different trade like tool and die or something would have experienced things like hundredth of an inch, or maybe in a machining type setting or milling. Anyway, nevertheless, we're going to practice all these various types of ways of rounding or trimming the answer to a certain precision or accuracy. The exercises are available on page 27, and there's a bunch of them here. We have, and also page 28, we have some questions involving rounding to decimal places, also identifying how many significant digits you have in a number or in a measurement. Finally, on this page here on 28, we have more rounding to various degrees of precision and also to their various accuracies or levels of accuracy. So I've actually just removed all of those questions and reorganized them here. So this way we can save a little bit of time. So these questions are coming from those 2 pages, and I've just taken a sample of as many as I can within reason to do with you. I think that you'll find that the first hour today was definitely the tougher one, because I literally just kind of you know, threw you in the fractions deep end of the pool and said, figure it out. And hopefully you've built up your confidence. But now we can kind of chill a bit and do easier questions. So let's take a look at all these questions and work through them. Hopefully fast, but not like lazy. So round each of these two quantities to 2 decimal places. So yeah, we're just gonna keep on going here. Yeah, that's 1.87. 1.87 centimeters. Yeah, so what you're doing here is you're just rounding to the second decimal place, but the only issue is this 6 here, do you make it a 6 or a 7? The number after it, if it's 5 or greater, you're going to round it up to a 7. So that's correct. What about the next question? Do we need to do any work on this one? It says 2 decimal places in the question. See that? The question is just that. There's nothing to do there. It's already at 2 decimal places. It's already at the correct precision. You don't have to change anything. There's nothing to do. It's already 2 decimals. Not necessarily a trick question. Hopefully it didn't trip you up too much. How about this question here? That's correct, yes. So just to give you a bit of a helping hand here, these are the digits you want, 2 decimal places. Let me just highlight them all. So that doesn't necessarily represent the answer. Everything is good until the last digit. So really you're just trying to figure out if the last digit moves up or down, moves up or stays the same. So that's all the game that you're playing here. So in this case, 22.6, is it 7 or 8? It's going to be 8. You see here, there's a 5 coming after it, so the 5 is going to round it up to an 8. We have it at 5 and up round. Yes, that's right. Senjit, thank you. If it's a 4 or under, don't round. If it's a 5 or up, round it. In this question, you don't round up because it's under a 5. It's a 4. So these two questions go together. They're companions. And then F, of course, is 22.68. Just give me 1 second here. So this is a weird one. If you go to the answer key, both answers are accepted. And the thing is that because it's on the fence, right? It's on the fence between 7 and 8. So this is what I'll say to you here. I'm coming out of a technical background, as you are also, many of you may have a technical background already. Depending on where I've seen different things, I've seen people round it up, keep it the same, and some people say one or the other. I will be very, very accommodating with all of the above. So if you wrote 22.67 or 22.68 in this case, I would accept it. Personally, I would write it as 22.68, but I'm not going to argue if you wrote it as either. And the reason is because there's various conventions that people use or various rules depending on what you want to do. I've seen a lot of different ways to do it, so I'm not going to worry too much about it. And I do think that this is not going to be an issue in this course because you're not going to get these nice numbers. You're not going to get a number that's on the fence like that. It'll always be a calculation involving decimals that there's going to be more digits later. So I don't think it'll even be an issue in this course. But like I said, I'll make sure to, as much as possible, um, avoid that situation. Sorry? No, it's two decimal places. So it's the two decimal places stay. They stay the same because it's already two decimal places. Yeah. Okay. So hopefully that wasn't too dangerous. These questions are much more valuable in terms of really getting some new knowledge for you. Significant digits is a topic that's often confused by people. So I'll just say this here. Ah, nice, Sanjit. So I'm just going to make a couple notes here. The rules are available in the book. I'll just say this. Non-zeros are significant. And then zeros, I'll just say that for now, and then I'll do some questions here and explain each of them separately. That's probably the fastest way here, okay? Because I do have a better way of doing it from my own notes from another course that I teach. But anyway, this is 4 significant digits. And the reason it's 4 significant digits is because the zero is sandwiched. What I mean by sandwiched, it's in between two non-zeros. What about B? The answer is actually 3. The 0 at the end is that 0 there. It might as well have been a 1. What if it was 14.1? Then you would argue that the 1 is significant. So it's just unlucky that it's a 0, but that's part of the precision of the measurement. We're trying to find a way to present this so that it's easy to read later. There we go. How about this one? That's correct, Nikolaos. Yes. That's 3. Those zeros at the beginning, they're just there to tell you how big the number is. How about this one? Jacob. Nice. 5. So I know the word sandwich is not professional, but I'll just say the sandwiched zeros are significant. Oh, it's 6. My apologies. It is 6. I didn't see the decimal there. Sorry, Nikolaos. My bad. I didn't see the decimal place here. Okay, I'm running out of space here. Let's move some 6. Okay, because this. Okay, to answer your question, Jacob. Jacob, do you agree that there's 3 here? Do you agree that there's 3 significant digits for this one? The one I'm covering over? Good. Same argument. See that decimal? The zero's after the decimal. Any 0 that's after a decimal has a purpose. That 0 had a purpose. Someone measured it to the nearest 5 decimal places. So that 0 there could have been a 3 for all you care. It wouldn't have made a difference. It's just unlucky that it's a 0 because it's confusing, but it's still going to be after the decimal. So any zeros at the end of a decimal are significant. These ones here are not because they're place values. So same thing with D here. For this one here to be 4? No, because these zeros here are in between. Any zeros that are sandwiched, see this 0 here that's a sandwich inside of 2 non-zeros? It's significant. These zeros are sandwiched in between non-zeros. So that means they're all significant. Everything is significant because the zeros are in between non-zeros. This one here, how many? Yep. So the 0 at the end, I'll just say precision and put dot dot dot. Because I wrote the same, I'm writing the same word every time there. I can type it though. Oh, you're so welcome, Jacob. I'm not here I'm not trying to chase anybody through these questions. I wanna definitely give you guys a fair explanation. How many on this one? How many zeros? Okay, 3. It's actually 4. So what's the consensus on this one? I think it's 5 as well. So it's I'll just say here, look, C, J. See question J? Same idea. Why is this 4 and not 3? Because both of the zeros are at the end of a decimal. These are at the end. So they're part of the precision. To answer Anas, another way to say it is to say, what if this was 13.99? Like, you know when you're driving in your car and then you know the odometer goes from 1399 and then it goes 1400, for example? It's the same thing. It's just rolling, the counter just moves up to the next level. So I'm going to copy whatever I said in J. And then 0, 0, sandwich 0. Oh, my friends, I ran out of space for L. I'll do P down here. I'll do P down here because I ran out of there. No, precision and accuracy are not the same thing. We're going to do that next class in us. Precision is not the same thing as accuracy. Precision, for example, is number of decimal places. That's an example. That's not the only case, okay? It's beyond just that. Accuracy, 100% for accuracy. This is always true. It's the number of significant digits. So in this case, this last one here for P, the answer is 4. And the explanation is this. I'll explain what these means. I'm just going to color it right now. Whenever you have a number in scientific notation, what I mean by these digits, I mean these numbers here. Any digits that you have in the front in scientific notation, so all these guys here, They are all significant. Doesn't matter if there's 2 digits, 1 digit, 10 digits, I don't care. Doesn't matter how many zeros are there. Everything's significant when it's written in scientific notation. So we're going to move on to the next page here. Now, again, this explanation with all these words, all of this stuff here, I'm going to convert this to a PDF and give it to you at the end of class. Round the following. Okay, so we're just doing some rounding here. P. Matthew, the short answer is this is scientific notation. And whenever you have a number in scientific notation, all of the digits that appear before the multiply, all of those digits are significant. That's it. So for all scientific notation, any digits that you see here, you just count them. And who cares if they're zeros? Doesn't matter if they're zeros. Everything's significant. No, the 10 to the 4 is a place value. That part of the scientific notation just tells you how big or small the number is. It doesn't that part doesn't have that part is not about significance. It's just telling you how large or small the number is. So in this case, the number is pretty big because it's tens of thousands. Okay, everybody, let's keep on going here. These are good questions. I'm glad that you're asking them. Round this number, this measurement, or quantity if you want, to the nearest 1,000th of a kilogram. What is 1,000th? Well, that's this, okay? If you want, you can say 1 over 1,000 or 0.001. So this type of question is just, again, more of maybe a language barrier than anything else, is remembering that thousandth with the th at the end means a fraction or a small number. So in this case, what would be the correct answer? 37 point what kilograms? What's the decimal part? Is it 6? What do you put here? 659 is correct. That's excellent. So it's just like the first question that we started with after the break, except I'm not telling you 2 decimal places. You need to decipher that yourself. So when you see 1,000th, you need to think about what level of precision is there. So that's a precision right here, okay? All of these questions are precision. Because when it says degree here, it means degree of precision. Let me just type in that up top here. When you see the word degree of precision, or sorry, the phrase degree, you can think of degree of precision or decimal places. In this case, you have a large number, so it's to the nearest 100. So you need to make the number actually less accurate than it appears. So that's going to be 49,800 feet. Now, I just said the answer this time because I wanted to say it a certain way. It says to the nearest 100. So when you look at this number, just ask yourself, is it closer to 49,700 or 49,800? And that's all I did there. I just asked that question, and it's not a coin. It is a coin flip in terms of guessing, right? Like you're going to get it right or wrong, but it's like literally one or the other. But when you have precisions that are larger than 1, then you just kind of write zeros. Well, you write zeros, as many zeros as needed for the precision. You might say to yourself, well, that's unfortunate. You're losing a lot of the accuracy because you are throwing away a lot of the significant digits. See, this one here has 7 significant digits of accuracy, but this only has 3. But why is that happening? Well, we're going to discuss why you would want to remove accuracy from a number or a measurement next class when we do applications and explain how the rules work for that. In this question here, it's kind of like question A. You're given the fraction, so the nearest 100th. It's meters per second. I'm just not writing the units for a second. We can re-say that as a decimal as 0.01. So this would be 12.08 or 12.09. Is it 8 or 9? What do you think? 8 is correct. Thank you. And one more, the nearest thousandth of a cubic foot. That's a nice one. If you can visualize a thousandth of a cubic foot. In this case, actually, it'll be 3 decimal places. So the final answer is going to be, I'll put the 0 in front. Some people, like the author, don't put the 0. Yeah, it's going to go to a 2. Thank you, Nicholas. So that's 672. Sorry. So there you go, a little bit of practice with precision. Hopefully that's something that you found useful. And more about communication than anything else. I think that you kind of get the sense of that there's a lot of communication to these questions. Not so much, I thought the 5 you round up. I did round up. Okay, sorry, Norris. Yeah, so this 5 here, yeah, no, it's okay. If this 394 wasn't here, just a hypothetical, just a hypothetical. If this 394 wasn't here, let me just erase that, okay, just for a second. Then, if you wrote 671 or 672, they're both right because it's on the fence. That's what the author of the book says, and that's what I'll stick to. Personally, I'd round it up, but that's my training, and everybody's training is slightly different depending on their technical background. But in this case, there's no real debate because there's other digits after there that push it over the half. So where does that leave us? Well, we have 10 minutes left because we should finish at 10:50 to the hour. And I've looked in the book here for practical questions involving decimals, which is basically just some exercises. So this next section is just basically like, I don't know, about 20, I think it's 24 questions. So I thought that we could just try as many of these as I've highlighted in blue as possible before 10:50 so that we finish class correctly on time. So I just chose a few on each of these pages. I don't know if it's realistic to do them all, but we'll try our best. So let's take a look at page 29, question number 4. And like I said, if you're wondering which question should you try on your own, with of course time permitting, I would do any question. See the stars? See the ones with the stars beside them? I'm doing some with you, and I'm doing some that aren't. Do all the questions that have stars beside them. That's the minimum I would recommend for homework. The author has taken their time really to explain the questions, but yeah, like I said, the bare minimum would be the starred questions. Express point 4 as an exact fraction in lowest terms. So we're going to just kind of go through these as these shorter questions quickly, but then later we'll get to the tougher ones and I'll try to do them a bit slower. So that's 4/10. You can always express a decimal as a fraction out of 10 or 100 or 1,000, etc. And then you can reduce it if necessary. How about number 7? So just doing the ones in blue here. So hopefully you can see where I'm highlighting it, because 1,000th is 0.001, whereas of course 1/10 is 0.1. So what would be the answer to question 7? Yeah, 161. Thank you, Nicholas. So Nicholas is saying to us what the last digit is. So that's like the clutch number to know. And then the next question is to the nearest tenth. So what would you put here? Yeah, 0.2. And you might be wondering, why would you want to round it different ways? It just depends on the application. It depends on the application. So don't get too distracted about why you would want to do one or the other. I'm not telling you why today. I'm just saying just do it. And then next class, we'll talk about why you would want to do one over the other and why you want to add or remove accuracy. Here's a neat little question. 17. What is the wall thickness of the metal in this diagram? Okay, what would that be? Let's do a calculation here on the side, maybe. I'm going to say it's half of the difference. That's right. So if you take that answer and divide it by 2, perfect. So what do you get when you subtract those two numbers? Now again, like I don't have my calculator, so I'm trying to do this in my head. What is that, 28,028? Can someone confirm? Can someone confirm on that? 14 thousandths of an inch? Anybody in the chat? It's a little quiet. Kuria's answer is correct. I'm just moving along with the calculation. Thank you, Matthew. Okay, good. The silence was scary. I was like, uh-oh. Did I break something? Okay, good. Yeah, in this case, I actually wrote the answer in English as well. I guess I can say it fully in English. The reason that you do that you divide by 2, is because the difference between these two measurements is 2 wall thicknesses. See that? See, there's a thickness here and a thickness there. I can set it up as an equation if you prefer. I can say that 2 thicknesses, or 2x if you want, is equal to that difference. Perhaps that makes it a little bit easier to read. Does that help a little bit, Matthew? Okay, cool. So that I didn't want to introduce any algebra there because the last thing I want to do is distract you with algebra when you don't really need to have it. I divided the answer by 2. I divided the, yeah. You're welcome. The funny thing is I get to type these equations here and make them look all fancy, but sometimes it's very annoying to line them up. So I hope you don't mind that the equal signs are not lined up. The half came because of there's 2 thicknesses. Here, let me answer the question a little bit differently because some people are getting cheesed about this. Anas, do you understand this statement here? Are you good with that one? Okay, then you're fine, man. Then you're fine. Here. Cool? So you have to divide both sides by 2, or multiply both sides by half, however you want to say it. It's good that you ask these questions, everybody. You're welcome. It's good that you ask these questions because then it tells me what your comfort level is. And I'm seeing more often than not, students actually like the algebra. They like the algebra, so that's good. So I'm gonna go and we have time for one more. I just chose the last one here. So this morning when I was having my breakfast, function flashbacks, yeah. When I was having my breakfast this morning, I was like, oh, let me look at the hard one. And anyway, this question here is, I would say, is like one of the harder ones, but it's actually not too bad. I just went back for a second. So we should move on because we only have one more question. We only have time for one more question, and I want to cover it because it's nice. Is okay, Cosmo? Okay. All right. So this is the last question in the section. Hey, why not? I said, let me try it this morning. So I was just like messing around for about 2 or 3 minutes. Anyway, so just a couple things here, okay? This length here in green, sorry, that's the radius of this big circle. So the radius of the big circle is 4308 meters. I just divided it by 2. And then also, the radius of this little circle right here is this guy divided by 2. So I did that as 24.64. So now the issue is how you get x. So this is what I came up with. I try to find like the cheapest explanation here. And I maybe I should have just said try this on your own and then give you a chance. But I also, I have a suspicion that many of you are curious about this one. I want you to call that little length in there A. Just call it A. So this is what I came up with. This is the radius of the little circle. So this also, let me just offset it a little bit. That's also the radius of the little circle. So from that, the answer, it comes down to a couple of calculations. So I can say here that A is equal to the radius of the little circle, which is 24.64 meters, minus the offset distance, which is these two goalposts, if you like, or the distance between the two radii, the centers of the circle, sorry, which is 13.73 meters. So that gives us A being, I did this by hand, and I got 10.91. And then from there, you're good to go. If you want x, x is going to be the big radius minus A. X is the big radius minus A. Which is going to be 32.17. So anyway, there's the answer to that one. I know that I may have rushed it a little bit, but I was just trying to get it across to you before we run out of time today. So hopefully, for those that had tried this, I think I had a couple students email me about this question, from one from your section and one from one of my other classes where they have the notes. So that's why I just wanted to bring it up in class briefly, just to share the knowledge with that person that was asking me before class. So there's the answer. If you were the person asking, there you go. Now, if I can match it with colors, because that's so satisfying to do. Whoops. No, you don't have to submit any homework, Cosmo. No, just the assignments, okay? But you're welcome to ask me questions about the homework. If you come across a question in the homework and you're like, what the heck is going on? I want you to email me. No, Sanjit. The whole, because the assignment is for marks, right? I can't do it like that. Yeah, that's the whole point, is that I'm gonna post solutions for the assignments after.